Dear members of the Korean Railroad Research Institute, I'm very honored to be able to present to you some facts about the DZSF and predictive maintenance, which is one of my special topics, especially the implementation of predictive maintenance. I first want to send you some happy greetings to your anniversary, especially from my former director, Ms. Professor Salander, who is now working at the Ministry of Transportation and is responsible there for the railroad sector. So let's start with a short overview over my talk today. First I will tell you something about the DZSF and the German Federal Railway Authority. Then we have a short overview over the basic principles of predictive maintenance. And in the end I will show you a few projects done by us in this field. To understand the role of the DZSF and the research part in general, it's important to have a short understanding of the development of the German railway system. And this starts mainly in 1990, or the complex part starts in 1990 with the reunification of Germany, where two state-owned railroad companies existed in Germany parallel. It was the Deutsche Bundesbahn in the western part and the Deutsche Reichsbahn in the eastern part. In 1994, the reform was made where these two companies were merged into one, NTB AG, which is a private company. It is still owned by the German state, but it is not an authority. As it is not an authority, it is not able to control itself. To fill this gap, there have been new authorities implemented. One is the Eisenbahnbundesamt, or the German Federal Railway Authority, which is talking about the safety issue, or which is responsible for the safety issues. And one is the Bundeseisenbahnvermögen. It's not big talk of this discussion right now. It's responsible for the properties those two companies own, which are not important for the transport part. They were given to the BFV. The part of research was not specifically assigned, so there is some lack of research that has been done in the time after 1994, especially about societal parts or other parts which were not interesting for the DB AG as a company. In 2004, there came a new agency into the race. It was the European Union Agency for Railways. This agency is the main part responsible for trying to harmonize the European railway market. It does so by mainly implementing a technical specification of interoperability, which tries to get harmonized rules into the European railway sector so that a vehicle operating in Germany may as well be operated in France. This is to some part possible, but especially in the command and control technology or in the electrical current, it is not that easy, but it's tried to get it more harmonized step by step. Which is important for us, since many rules now are set on the European level. There are national assignments for every technology nearly, which can be done by the nations. But the main rules are set at the European level, and that also makes it a little bit harder for us as a national research agency, since we need to develop solutions that may be applicable in all of Europe. On the slide before, I said that in 1994 the research was not assigned to a specific institution. So there was a lack of research done for the government. So 20 years later, in 2015, a first research department was established at the Federal Railway Authority, which will be the starting point for the Rail Traffic Research Center we are creating right now. In 2018, this institution was then set into a governmental decree. And in 2018, the Ministry of Transportation and Digital Infrastructure ordered us to found this German Center of Rail Traffic Research. So in 2019, we officially opened the DZSF. Yeah, and we are operational since then. In the first year, we got about 60 researchers, which is now about the size we are at. We are 65 to 70 people right now. And another milestone for us was in September 2022. The MOU with the KRRI is the first cooperation we have outside of the EU, and we are really looking forward to fill this cooperation with life. Our official tasks are to implement our federal research program for rail transport, which is revised every 2 or 3 years. We will take care of the railway sector and the scientific community in the development of the federal research program and in starting projects together with them. We assist the federal government through scientific decision support, especially in railroad issues or transportation issues as a whole. And we try to implement our results in the market by examples. If that's not possible just by example, we also have the duty to find ways to get the sector to accept the research results which are beneficial for the whole system. So this slide shows our organization, and it will also give a short room for my introduction. First, we have 2 parts of supervision. We have an administrative part, which is done by the Eisenbahnbundesamt and the president Gerald Hörster, and we have a technical supervision from the Federal Ministry for Digital and Transport. Our director is at the moment not set. Ms. Salander is, as I said, now responsible for the railroad sector in the Federal Ministry. I hope we will get a new director in 2023. We have a scientific advisory board with which are German experts on different fields, from society to technical questions and everything like this. We are working in 5 different areas right now, which we structured like strategic planning, which is the long-term assessment of the DZSF and includes international cooperation. Ariane Böhmer, for example, is working there, who has made the MOU with the KRRI. This part is led by Andreas Eckel. The part of economic efficiency is led by Merle Ort. There are questions like building infrastructure and vehicles and things like this are done in this research field. Then we have the research field of environment and sustainable mobility. Eckhard Roll and his team, there are 2 projects to new biological species in Germany, and things like climate change and sustainable mobility, which is then for alternative technologies in mobility or renewable energy and things like this. The whole part of safety is done by Martin Lienert. There are things like command and control system, but cybersecurity, critical infrastructures and things like this. And the last part is digital technologies. This is my part. Digital technologies, we have 2 major topics in this research field. One is predictive maintenance, which I will present later on, and the second one is autonomous driving. We have some further roles in the German railroad system. For example, we are controlling the funding program for the future rail transport. This is belonging to Andreas Eckel's part. And a technical part is we are part of the BMDV network of experts. It's a group of experts set together for different questions like climate change, maintenance and digital technologies, or the calculation of future transport needs. After 10 minutes of organizational matters, now let's start with the technical topic of this discussion. And we will have a closer look at predictive maintenance. First, we will start with the concepts of maintenance in the German standardization. There we have Deutsche Industrienorm 31051. And the quote there is how we understand maintenance. This should be the same all over the world. But maintenance is basically parted in three basic functions. First, there is servicing, which is the usual process to keep everything in shape, to be working, like lubrication, cleaning, and things like this. This is a topic we are not very concerned about. That's not the part we are looking for in predictive maintenance. The other two are part of the thing, and predictive maintenance bases a lot on the part of inspection. The knowledge about the quality of the system and the condition of a system is basic to do the right decisions, and repair is just the measure that comes afterwards when there is a damage or when there is a damage prognosed. So that's the part afterwards. So the main focus for us will be on inspection, but that we will see later as well. We also make approach to the topic of predictive maintenance by not separating too much between infrastructure and vehicle. Of course, the measures are completely separate, and even some methods for the analysis are different. But the systematic approach is the same for both. And there's also a target conflict, which we define in that way. We keep safety out of the conclusion, since safety is not there to be any matter of discussion whether to have it or not. We don't want to strengthen safety by a large degree, since more safety is very expensive and keeps the operation very difficult. So our interest is to keep safety on a level near the same to now, or improve it a little bit, but not too much. And safety is also regulated in laws and regulation already, so we don't need there to change too much. What we need is some sort of flexibility in safety, but we need to prove that thereby safety is not diminished in any way. The real targets for us in the process of maintenance are the part of capacity, which for us is the performance or the number of trains that can be operated on a track. Then we have the quality, which for us is something like the reliability or the usability. When we need a track to be operated, it has to be operated. And the third target would be the costs. It should be as cheap as possible. Those three for us are in some sort of conflict. Usually, for example, the quality can be high if there is not one train operated. The wear is very low. So capacity and quality are in some sort of conflict, and the costs, of course, are in conflict as well. We at the DZSF cluster maintenance in these four different levels. Let's start at the bottom with reactive maintenance. That's the most easiest one. There usually maintenance is done after a failure occurred. So after any component is not doing what it should do, it is replaced, repaired, or whatsoever. Preventive maintenance is the next step. Their components will be changed before a failure is very likely. There are different levels of likelihood when components are changed. This strategy usually leads to that components don't get up to their lifetime, so they are replaced much too early, and so you need much more components that are quite okay to be replaced by new ones. So there is a lot of lost money in the system. Condition-based maintenance relies on a permanent assessment of the conditions of objects, and when the wear of a component gets to a critical level, or when failure is near, you are going to have the maintenance measures there and try to replace or repair the component. This system already needs a lot of information, but just to get the right condition level. Predictive maintenance is the next step on this list. it's completely based on the condition of an object, but you also use prognostic models to see what future wear on a component is expected, and so you can estimate what time you have till you need to do maintenance. So the last level is that which needs the most information. And these are the information requirements. The reactive level, as I said, is quite easy. You just need the information about a failure, then you get operational. And when preventive maintenance, you need statistics about failure, and you need the expected load spectrums on this component. On condition-based maintenance, as I said, you need a permanent assessment of conditions and some models for the remaining lifetime. And with predictive maintenance, there it gets a little bit more complicated. You need prediction models, which should be reliable and known. And you need to understand cause and effect of different effects like weather, load spectrums that are most likely to happen and things like this. So it's the hardest thing to couple the real condition information you have from reality with the models you develop for prediction. So why are we doing predictive maintenance if it's so much more complicated? For us, it can be described in this figure. On the left, we have our situation of today. We have a large part of reactive maintenance, some preventive, and for a few parts we have condition-based maintenance already in place. And in the future years, we expect that this level of maintenance may shrink when we use more advanced measures of maintenance. So the easiest levels like reactive and preventive will go down. Condition-based will be a much larger part, and predictive maintenance should be for some high-risk buildings or for cost-effective buildings. We hope, therefore, that we can use this new free room above those measures to optimize our infrastructure. This can be, the target conflict. This can be by capacity, it can be reliability, or it may be reduced cost. What will be the potential we should use may be different for every track we see, or it may be a political decision what we should do with the new threshold for different approaches. As told before, information is the most basic requirement for using predictive maintenance or even condition-based maintenance. So this is the setup of today. So how do we get information today? Basically, humans monitoring vehicles or humans monitoring infrastructure. This is a data set we can already use and access, but this is usually a really limited data set. So there are far more advanced options for data acquisition. For us, there are 4 more ways to gather information by right now. It is first that infrastructure is monitoring itself, so a bridge is monitoring itself. A vehicle is monitoring itself. A vehicle is monitoring the infrastructure very broadly. It can drive by and have a camera and monitor thereby very large parts of the infrastructure, and the other way around, infrastructure with a set of sensors can monitor every vehicle which is driving by. A first example for measuring infrastructure by itself is the switch diagnostics, where the current consumption of the switch motors is measured and thereby the condition is assessed. This is already in use at about 30,000 switches in Germany. A research project is the track testing. Their sensors are used to measure the condition of tracks, and on an IA-based assessment, it should be possible to find more information about the condition of the tracks and find problems with the track much sooner than right now. Another thing is sideway detection, where the infrastructure is monitoring vehicles. Thereby usually cameras are used to assess the wear of components, like here for the pantograph. This is used in very specific conditions right now, but not broadly used in our infrastructure. And another thing, this is in development as well. That's maybe a wheel set detection, whether a wheel set is wobbling or not. And this can be done by acceleration sensor. There are a lot of research is done, but nothing is quite in usage right now. So here is a German slide, which is not so important to understand everything. Important is that there are usually two major advantages of using predictive maintenance. And this would be there's improved possibility for the planning of maintenance. If you use predictive maintenance, you can group separated measures into one for easier or shorter track closure. You have a more efficient planning of resources by a longer preparation times, so you get the right maintenance group to do the right work. And you have a better usage of components, so you can use more to their real lifetime. You can use components until they are really damaged or until the wear is at a level where it's not anymore appropriate. And you have the possibility to understand the effects of wear and degradation much better, so you can optimize components that will be used in future to be more rigid versus the requirements that are in the field. So let's change to the challenges we address by our projects right now. We cluster them usually in 5 topics. One is data related, technological, organizational, economical, and legal. Not every project addresses every topic, but yeah, you will see it on the slides right now. But it's not so important for you to organize it. It's just important for us, so we know which team is working on it. First, there's a concept for a data platform for predictive maintenance data that is generated in the system. In Germany, there is quite some problem about exchanging data. There are companies which don't like to have their data given to other proponents in the field, and the trust there is not that big, so it's quite problematic to get all the information out of the data that are available. We are trying to establish some sort of data platform so that we can be sure that the data is there where it needs to be, so we can have a more efficient maintenance. Another problem tries to find out which methods for diagnostics and prognostics are the best we can use for our railway system, or for which part of our railway system. There may be more than one method appropriate for operation. We try to find out what potentials those methods have, what limitations they have, and which methods should be more in our focus for future research and development. The economic viability and amortization analysis is about to try to find out which of these methods, which are usable in the project from before, are cost efficient and will bring cost benefit to us. And the cost benefit is this part where we can get more resources, or we can try to get a better system in work. So the target conflict, if you remember from one of my slides before, that's the part where we try to get more cost-effective measures right here, so we can have a larger part of freedom in getting better capacity or better quality or a better cost efficiency. One of the next real big questions for us is the adaptation of requirements for regulations. This is mainly the analysis where our rules and laws are at the moment not appropriate for the use with predictive maintenance, and not even compatible with condition-based monitoring. There are often some time frames set and requirements set which prohibit the use of condition-based assessment of components. We need to change this in order to get more enhanced maintenance measures in the field. So that's it with my short presentation about the topic of predictive maintenance and a short introduction of our institute. I'm really looking forward in getting cooperation with you in new research projects, and I really hope we will be in contact soon. If you have any questions about this talk, please contact me. I will really like to talk to you, even if we have to find a date which might be a little bit difficult with the whole time discrepancy between Germany and Korea. But I'm really looking forward to exchanging knowledge between our two countries. So have a nice anniversary celebration, and I hope we will see us soon. Goodbye.